Trying to get you ready for the rest of the course, and this is the. You got pneumonia? You don't have pneumonia, do you? You're not gonna pass out, right? Get you ready for the rest of the course. This section that we're going over, these 2 or 3 sections of homework, is the foundation for the rest of this course. So if you suck at this, you're going to suck at the rest of the course. If you don't do the homework for these 2 or 3 sections and know what you're doing, you're going to suck at the rest of the course. Just like if you didn't review your algebra concepts, you're going to suck at this. So just telling you, I'm trying to lay the foundation out in these 2 parts, the algebra review and the basics, the basic 3 or 4 properties of calculus. Once you get those down, the rest should be okay. All right, you have to rely on a little bit of thinking. All right, you know, thinking.
An email has just arrived.
Sorry about that. Where's my handy dandy whiteboard? Turn the front lights off, please. There we go. So let me pull up. There we go. So we can go ahead and do the first outer inner last. So that'd be 7x to the 4th minus 56 or 42. It'd be 42, sorry. Oh, we got the eraser today. 42x minus 8 or plus 8x cubed minus 48. 8 times 6 is 48. Y'all check me on that. So that'd be 7x to the 4th plus 8x cubed minus 42x minus 48. That's going to be 28 x to the 3rd plus 24 x squared minus 42. So that would be your derivative. Now, if you did it the other way, first 7x plus 8 times the derivative of the second. What's the derivative of x to the 3rd? 3x squared, right? Plus the second times the derivative of the first. 3x squared times 7x squared is what? 21x cubed and 24x squared plus 7x cubed minus what? And 21 plus 7 is plus 24x squared minus 42. Oh my, look at there. You get the same answer. Now, just for giggles, go ahead and try the difference quotient. Try it with that right there. Let's see what happens. College football wasn't too pretty this weekend. South Carolina really looked bad. Well, it didn't look as bad as Clemson. And then Georgia barely pulled theirs out.
Just a little something. Was it the last second?
And the lateral, yeah. How did that coach throw that football? I mean, the plays before that, it was a controversial play. Why was it controversial? What? Yeah, that's it. The intentional grounding call. That's what did it. Okay, so who does Clemson play this week? Do they play Tri-County Tech? Who do they play? You're kidding. And then Clemson fans wonder why they don't get their respect. Who else? Who does South Carolina play? Please don't say Alabama, please. Alabama's going to take it off. I mean, I think. What? For what?
Talking about his attitude with the media, like first couple of years, he was like the side was good, and this later was like not liking the attitude or whatever in the press. He's saying like that's affecting how we do.
Well, the quarterback is the offensive leader, and the linebackers are the defensive leaders. So, yeah, I would say that. Yeah. At least he admits it. At least he says, "I'm sorry." I think Clemson has bigger problems than that. I got a friend there's a fan, and then there's the crazy people. He's a crazy person. And he says that Clemson was playing down to Troy State. Or Troy. I'm like, okay. Was that playing down when he fumbled the ball before he got into the end zone? That's exactly what I said. Oh well. Now who does Georgia play this weekend? Anybody know? Anybody know who Alabama plays? Okay. Nobody knows anything in this class. But you know how to take the derivative, right? All right, so y'all give me this on the whiteboard and okay. That's not supposed to happen. Okay. All right, so limit as h approaches 0. Sorry, should have turned that off before this. Oh, the tutoring center. Did y'all see the latest announcement on the tutoring center? They've embarked on online tutoring. Only 2 years late. Sorry. Bad. All right, give me the, well, we'll go ahead and we'll go ahead and just give me the problem. What is it, 7 what?
7x plus 8 times
7x what?
Okay, you want that one.
Yeah, 7x
to the 4th.
7x to the 4th.
Minus 42x
42x
plus 8x to the 3rd.
plus 8x to the 3rd
Minus 48.
minus 48 minus, I'll give it to me one more time, 7x to the 4th
That's 42x plus 8x to the 3rd.
all over h. Oh yeah, this is gonna be fun. So limit as h approaches 0 of 7 times x plus h squared times x plus h squared minus 42x minus 42h plus 8 times x plus h quantity squared times x plus h minus 48 minus 7x to the 4th plus 42x minus 8x to the 3rd plus 48. Okay? And that's going to be limit as h approaches 0 of 7x squared plus 2xh plus h squared times 8x squared plus 2xh plus h squared minus 42x minus 42h plus 8 times x squared plus 2xh plus h squared times x plus h minus 48 minus 7x squared x to the 4th minus 7x, I'll go romper room for this 40 line, plus 42x minus 8x cubed plus 48. Then limit as h approaches 0, and that's going to be 7. You ready? X to the 4th plus 2x cubed h plus x cubed h squared, oh, I'm sorry, x squared h squared, right? That's a plus. Okay. Plus x squared h squared plus 4xh x squared h squared, sorry. I skipped a step.
Why do you just do this like at the beginning above that? Why do you break it down to like x plus h squared plus x plus
So you got to multiply all these terms. You got to multiply all this. You got to get every term in a separate place so it can cancel out. So that's going to be 2x cubed h, right, plus 4x squared h squared plus 2xh cubed plus h squared x squared plus 2xh cubed plus h to the 4th minus 42x, that's supposed to be 42x, yeah, minus 42h, let's do it out of cluster down here, and that's going to be 8 plus 8 times, that's going to be x cubed plus 2x squared h plus x h squared plus hx squared plus 2xh squared plus h cubed, and then minus 48 minus 7x to the 4th plus 42x minus 8x cubed plus 48. Limit as h approaches 0, and let's see, that's going to go all the way to, let's see, h 4th. Where's h to the 4th? That's right here. So I've got to distribute that to 7. So that's going to be 7x to the 4th plus 14x cubed h plus 7 x squared h squared plus 14 x cubed h plus 28 x squared h squared plus 14 x h cubed plus 7h squared x squared plus 14 x h cubed plus 7 x to the 4th minus all of this. Now we got to take the 8 and we got to distribute the 8 here. So y'all get the picture? Yeah, I quit. Sorry, I threw it on the towel. Maybe it'll work better now. I'm sorry, I forgot it had a battery in it. Hold on. Let's see, where's the little spring? Maybe that's why it's not working. Huh.
There's something behind the foot.
Piece of paper. I thought the little spring was supposed to. Oh, there's the little spring. It's on the other side. Okay. Okay. The whole point is, you see that you can get yourself into a cluster with this. But I saw a 28 somewhere. Didn't we have an answer with 28 in it somewhere? I mean, you might can see some of the things start to cancel out. I don't know. There's a whole lot of junk in there. There, that says 7x to the 4th. See it over there? That cancels. Y'all see anything else? It cancels. Good luck. You might see some things that actually, at x cubed h, that's 28x cubed h. Seven x squared. There's 7x squared h squared plus what's 7 plus 28? 35. I have no idea. I'm just going. We may have to cancel something else out. I mean, add something else to it later. I'm just trying to condense. There's another x squared h squared, which can go with this 35. 35 plus 7 is what? 42?
14 is x cubed. Yes,
Where, this one?
yeah, that one.
That one don't cancel, that's 28. Well, we'll see if it doesn't cancel. I may cancel, I might have messed up. Okay, where was I? 42? Okay, that takes care of, I added that 7/8 right there, right? Now 14 plus 14 is 28. 28 x cubed. And I know I got a lot of stuff down here, but right now I'm just trying to condense a little bit. And that takes care of that one. 7h to the 4th. Doesn't that cancel somewhere? I guess not. Okay, let's just keep going. I'm going to finish it. All right, that 7h goes here. So plus 7h to the 4th minus 42x minus 42h plus, I don't know how I'm going to put all this in, 8, I'm just going to put it right here, 8x cubed plus 16x squared h plus 8xh squared plus 8hx squared plus 16x h squared plus 8h cubed. That takes that out. Plus 42x, no, minus 40, that minus 48 cancels with that 48. Anybody see a 42x anywhere? 42x right here, cancels with that 42x. Anybody see an 8x cubed? That 8x cubed cancels with that 8x cubed. And now we're talking about, let's see down here if we can do anything. How about that 8x, that's 16. I'm looking. This 8x and this 8x, the 8x, no, that's not. 16, okay, I'm looking. Right here. I'm looking. Oh, these two right here. That's 14 or 24. Do we have another one of these? So I'm going to take this 16 and this 8 and put 24 h x squared. Is that right? And then this 8, what's 16 plus 8 here? This 8x squared and this 8, that's 24 x 8 squared. That takes that out of that. And that leaves 8h cubed. All over, don't forget your h down on the bottom. Okay, this is fun. Let's go to the next. Let me see if I can squish this down.
The answer was 28x to the third.
We ain't nowhere near the answer yet. We're nowhere near the answer. Actually, I love this kind of stuff.
Why don't you take this, like, scroll down?
Oh, that would be too simple. But we went over that in training. And we'll make that a little bit smaller. Y'all help me out when I write this out because I want to make sure I ain't missing anything. So limit as h approaches 0 of, make sure, 7h to the 4th. Is that canceled? Yeah. No, did I bring it down? Yeah, there it is. Okay. I want to make sure I hadn't missed anything else. All right. 28 x to the third h plus 42. I don't know what that mark is, but I hope it's nothing. H squared plus 28 xh cubed plus 7h to the 4th minus 42h plus 24hx squared plus 24xh squared xh squared plus 8h cubed all over h. Now, is there anything in there? X cubed h. Nope. X squared h squared. Nope. 28xh cubed. Nope. H to the 4th. Nope. Do y'all see anything that can combine? Xh squared. There's not these two right here, right? Are those the same? No, they're not the same. Okay, is there any other? So let's go ahead and factor out. Looks like, can we factor out h? That's one way to tell if you know what you're doing or if you're along the right track. Limit as h approaches 0, and that's going to give us 28x cubed plus 42x squared h plus 28xh squared plus 7h to the 3rd minus 42 plus 24x squared plus 24xh plus 8h squared. Y'all check all over h. And then that cancels limit as h approaches 0 of 28x cubed plus 42x squared h plus 28xh squared plus 7h cubed minus 42 plus 24x squared plus 24xh plus 8h squared. And then take our handy dandy red pen, and that limit guy takes out this guy, takes out this guy, takes out this guy, takes out this guy, takes out this guy. And we're left with 28x cubed minus 42 plus 24x squared. Somebody tell me what we got for the answer. Of course it is. Dang, don't make feel good do stuff like that.
I was just, I quit after
Well, at least you're honest.
That's the honest. I remember my paper, don't do it unless it says it.
Well,
That's way easier.
the whole point of me showing you how to do this is, like you said, if it says do it, do it. But if it don't say do it, use this one as a last resort, because you get yourself into an algebraic mess. But anyway, I felt some of my Clemson blood flowing then, doing about 6 of those a night.
You look extremely smart.
Yeah, thank you. I thought I'd get me a window, maybe start on the window, then I could start acting like John Nash. Bust my head up against the window. Some of y'all have no idea what I'm talking about, but anyway, let's do the second one now. Let's go to the transparency, and I think I've pretty much shown you how not to do it. Let's do this one. Of course, you could actually do this one. Now that you know the chain rule, you can do this one. You can do this one several different ways. Somebody name a way you can do this one. I'll go ahead and name the first one, the quotient rule. Okay, that's what it says right there. But what else could you do? Huh? How? Tell me how. Good job. How'd you know that? Good job. Bring the x to the fifth plus 1 up, and that would be x to the fifth plus 1 to the negative what? To the negative 1. Then you could use the chain rule with the product rule. That's what you need to be doing with these type problems. When you see there, use the quotient rule to differentiate the function, you do not sit there and go, okay, I'm going to use the quotient rule. Okay, I'm done. You need to figure out other ways to do it, because calculus, why do you spend 3 years of calculus to be an engineer? So you can waste time? No, because the whole purpose of calculus, the whole purpose, write this down, is to manipulate a problem. That's the whole purpose of calculus. To take a problem, take it apart, turn it inside out, and then rearrange it in another way and solve it. That's the whole purpose of calculus. That's why you have to take three daggum courses of it before you make a bridge and people won't fall off. All right, use the quotient rule. So we're going to do that first. Denominator times numerator prime minus the numerator times the denominator prime over the denominator squared. Okay, what's the derivative of that? Yeah, thank you. Can't talk today. So that's 1. And the denominator prime is 5x to the what? So that's going to be x to the fifth plus 1 minus x times 5x to the fourth. And of course, that's to the first and that's to the 1. So 1 times 5 is 5, and x to the first times x to the fourth is x to the fifth. So we've got x to the fifth plus 1 minus what? 5x to the what? And what's 1x to the fifth minus 5x to the fifth? Negative 4x to the fifth plus 1. Now do it another way. I'm sorry, what? Oh, yes, over the denominator. I'm sorry. Thank you. X to the fifth plus 1 squared. Now remember, not many times are you going to do anything with that x to the fifth plus 1. But if you feel like you want to do some extra algebra, you change it to what? X to the 10th plus 2x to the fifth plus 1, if you wanted to. Put some change if you like that, that's fine. But really, there's no point in doing the denominator unless you see that something's going to cancel out. All right, do it another way. Actually, there's two other ways you can do it. One is bring x to the fifth plus 1 up. The other would be bring the x down. And then you have 1 over, and you can do it that way. But the only thing we'd be doing the product rule in the denominator. So that's the 3 ways you can do it. And we'll take it to the next page. I'll just cut this thing out using the cutting tool. You ever seen Goodwill Hunting? Notice. Don't watch movies at all. Huh? Yeah. Y'all just don't watch movies anymore, do you? Yep. The associate professor, the little guy that followed the tall professor around, he's the actual professor at MIT. And he would tell them what to write on the board. As I said, those actors are pretty stupid. I guess you have to be stupid to try to act like a math professor. All right. That's true. Yeah, that's very true. All right, this one you can bring it up or you can bring it down. F of x is equal to 1 over x to the fifth plus 1 times x to the negative 1. You can do that. Or you can do f of x is equal to x times x to the fifth plus 1 to the negative 1. So f of x, f prime of x, is going to be equal to, and you can do the quotient rule here, but there's no reason to because you've got just 1 there, so it'd be 1 over the first times the derivative of the second plus the second times the derivative of the first. So f prime of x is equal to 1 over, and that's going to be x to the 5th plus 1, and then this is going to be negative 1 to the negative 2. Somebody check me. Negative 1 x to the negative 2 plus x to the negative 1 times 1 x to the 5th plus 1 to the plus 1 minus 1. 0 power times the derivative of what's inside is what? 5x to the 4th. F prime of x is equal to 1 over, and then this is going to be x, going to distribute that x to the negative 2 through here, so that's going to be, I'm going to rewrite it, x to the 5th plus 1, negative x to the negative 2, plus, well, what is anything raised to the 0 power? Okay, I heard everybody say 1, so that goes to 1. So 1 times 1 times 5x to the 4th is 5x to the 4th. So that's x to the negative 1 times 5x to the 4th.
Wait, how did you get earlier? When did you do all that for? You just moved all up for yourself.
What do you mean?
You had x to the negative 1, you did all that crap in the second.
Right here, I did the chain rule. So I don't forget the chain rule, so I remember to do what the chain rule says. I don't just skip it because how did you know there's going to be a 0 here? You have to know the chain rule to know that there'll be a 0 here. I'm doing it for the practice. I'm doing it for so you'll know how to do the chain rule. And when you get confused, you can always go back to the basics. There's a 1 there. So that means 1 comes out front, and then 1 minus 1 is what? 0, and then the derivative of what's inside. So, now, f prime of x is equal to 1 over, and then negative x to the negative 2. I'm going to write this out because some of you are going to forget your exponential laws. Negative x to the negative 2 plus 1 times negative x to the negative 2 plus, and that's a 1 right here, 1 times 5 is 5, and x to the negative 1 times x to the 4th is what? X to the 3rd. And now we're just going to clean this up. So let me clean that up. Now, how you need to do every single step that I'm doing? Yes or no? Well, it depends on you. Okay? And what you know and what you don't know. What's my job? To show you how fast I can do the problems? No. My job is to show you how to get yourself out of a hole when you get confused, or how to start a problem or finish a problem when you get confused. So that's why I'm writing all these steps. So f prime of x is equal to 1 over, there's a 1 here, and there's a 1 here, negative 1 times 1 is negative 1, x. 5 minus 2 is what? 3. Minus, that's a 1, negative 1 here, so that's negative 1, x to the negative 2, plus 5x to the 3rd. And f prime of x is equal to 1 over, what's negative 1x cubed plus 5x cubed? Be 4x what? Cubed. And then minus x let's see, that comes out with minus x to the negative 2. I don't know what the answer was to begin with. What was the final answer on the previous page? We still got to do the quotient rule. Yeah, we've got to do, now we can do the quotient rule. Or you could do the quotient rule at the beginning with the product rule. We still got to do the quotient rule. So that right there, and I'm going to put right here with quotient rule. And then you should be able to get your final answer. Here, first times the derivative of the second plus the second times the derivative of the first. I'll do that one for you. One. All right, so that's f prime of x. F prime of x is equal to x negative 1 times x to the 5th plus 1 to the negative 2 times 5x to the what? 4th. And that's the quotient rule. I mean, not quotient rule, chain rule. There's this term right here. Plus x to the 5th plus 1 to the negative 1 times what? What's the derivative of x? So I'm going to take my handy red pen and I'm going to put this in brackets. This in brackets. Red brackets. And that would be this in brackets. And then blue. And this in brackets. And that. Okay, so that's going to be f prime of x is equal to x, and let's clean this up a little bit. What's 5x to the 4th times negative 1? Negative 5x to the 4th, x to the 5th plus 1 to the negative 2, close brackets, plus, and that's just x to the 5th plus 1. I'm just going to put that in brackets because that's 1 times that. I can multiply this x times this right here. That's x to the 1, that's 1x to the 1. So f prime of x is equal to 1 times negative 5 is negative 5. X to the 1st times x to the 4th is x to the what? 5th times x to the 5th plus 1 is negative 2 plus x to the 5th plus 1. Now all that's over what? 1. What am I going to do with this guy? Bring it down, and that's going to be f prime of x is equal to negative 5 x to the 5th plus x to the 5th plus 1 over x to the 5th plus 1 raised to the 2nd power. And then what's negative 5x to the 5th plus x to the 5th? Negative 4x to the 5th plus 1 over x to the 5th plus 1 to the 2nd power. What was our original answer on the previous page? Okay. The reason that this one is complete is because with the product rule, when you move that up, you've got the product rule, that's it. Over here, when we move this down, we started the product rule, but we also have to do what? Quotient rule, which would be, I would say this one would be a whole lot more difficult. Okay, so there's 4 ways to do it. One is to use what we use, I don't know what we used on the previous page, but use that rule first, okay? Quotient rule. That's the first way. Then the second way would be bring it up and use the product rule. The third way would be doing this method, but don't forget to either do the quotient rule down here, and I would preferably do the quotient rule up there with the product rule. So this is quotient rule plus the product rule, and then of course the fourth way to do it would be difference quotient. Again, I'm not asking you to do all 4. What I'm asking you to do is just look at other ways to do it, because that's what expands, that's what engineers do. All right? So, let's do a nerd. Question?
So a function to say negative power times derivative equals -2. The power -2.
What now? You gotta show me what you're talking about.
Second row up there.
Right here.
What about that? Yeah, x to the -1 to derivative.
Well, this is the derivative. I'm taking the derivative of this.
Yeah.
That -1 comes out front. And then x plus, that's right there. And then what's -1 minus 1? You always subtract 1. That's the power rule. And then take the derivative of what? What's inside? Oh, let me ask you one question. Where is the actual calculus in this problem? Here and here. What else? What's left? All right, let's try nerd. Clear this. Clear this. Let's go down. Try, that's called the second derivative. That's called your velocity. First derivative is the velocity. Second, which one is it? Acceleration. First derivative is velocity. Second derivative is acceleration. All right, let's try these two. That ought to discourage you. Find the derivative of the algebraic function. (14 and 15). Give you a couple of minutes to get discouraged and quit, and we'll go over it.
14 is that x to the 5.
Yeah, x to the 5th minus 1. Now, of course, you could bring up the denominator and do the chain rule with the power rule. That's about the only way I would suggest doing it other than this way. Because they are getting more and more advanced, more and more challenging, so chances are you're not going to go with either way. If they tell you to do it, or they don't hear quotient rule first, or bring up the x to the fifth minus 1 to the negative 1 and use the power rule. That's about it. So, give y'all a few more minutes for the rest of the work. I did what? No, I got 14, 16, yeah. So I went down to the College of Charleston to visit my daughter. It's her first semester today. She had to take me on a tour of Charleston like I've never been there before. I had to keep my mouth shut. We had to ride the trolley. I thought a trolley was electric. I told her, I said, this is a bus. This isn't a trolley. Hey, you're in Charleston. It's a trolley. I'm like, oh, I'm sorry. Saw a guy dancing on the side of the sidewalk. On the sidewalk, he was dancing to Michael Jackson. He wasn't doing too well. Then the guy got on the bus, and he was talking to himself. I mean, he was carrying on a conversation with himself. He wasn't talking to yourself. You know how you talk to yourself? Okay, do I need to go here? Do I need to go? He wasn't doing that. He was answering himself and carrying on a conversation with himself. So I guess the crazy people are moving in on Charleston too. And then there was this one guy, he was hollering at people while they were walking down the street. He was on the side. And people would walk by and he'd say, go to hell.
Oh, God.
So what do? You just keep walking. I said, you the one that made the decision to come down here. It was a good visit.
We should have done this sort of people
No, I don't want to get involved. No. We tell people to go to hell just walking by, just.
I'll take you to church right now.
I'll put him over there with the guy that's talking to himself. Maybe they can figure out the world's problems. And then if they can't, they can go over to the Michael Jackson guy. Interesting. All right. X to the fifth minus 1. Negative 3x what? Squared minus 3. That's not too bad. Why not put brackets around the second part?
Negative sign?
Because that guy right there will mess you up. So you better make sure you got something to say, okay, I'm going to distribute that negative. That's what these brackets do. So, negative x cubed minus 3x plus 1. And the derivative of x to the fifth is 5x to the fourth. All over blah, blah, blah. Oh my, we got to use the FOIL method here. So we're gonna go ahead and cut this out and go to a white page because I ain't gonna finish it in that little bit of space right there. Or we could just quit and call it a day. Yeah. Yeah, we'll do it at home, right? Where's my snipping tool? I got rid of it. Wow. Let's see if I can copy this out. Yeah, I did this in training. I don't know what I did. Oh, there we go.
Oh, okay. This is so fair.
Okay, so that's, make sure that's 5x to the 4. Make sure I got everything. I did. So let's save that. And let's go to the whiteboard. Alright, so gotta use our FOIL method here, and that's gonna give us negative 3x to the 7th minus 3x to the 5th plus 3x squared minus plus 3, y'all check me, and then minus brackets 5x to the 4th times negative x to the 3rd minus 3x plus 1 all over x to the 5th minus 1 quantity squared, negative 3x to the 7th minus 3x to the 5th plus 3x squared plus 3 minus 5, be a positive 5x to the 7th, positive 15x to the 4th, nope, 15x to the 5th, minus 5x to the 4th. Y'all check me on that, please. Over x to the 5th minus 1 quantity squared. Negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative, no, positive is a negative. 5 times 1 is 5. 5 times 3 is 15. 5 times 1 is 5. X to the 4th, x to the 7th, x to the 5th, x to the 4th. So that looks right. Now, what is negative 3x to the 7th plus 5x to the 7th? Negative 3x to the 5th plus 15x to the 5th be 12x to the 5th. I don't see anything else, y'all. Minus 5x to the 4th plus 3x squared plus 3 over x to the 5th minus 1 quantity squared. Now, that's shortcut number 2, which will give you what? X to the 10th minus x to the 5th plus what? 1? You're not going to be able to do anything with that. So, is that what y'all got? Good. All right, let's do the next one. And yes, we could bring that. Hold on. Let me get out of this. No, that's not what I want. Transparency. Clear. You could bring that x to the 5th minus 1 up, and that would be x to the 5th minus 1 to the negative 1, and then you could do the power rule. And that's doable. All right, let's do this one. I'll just go ahead and fill it out. I done erased the whole setup, so I can't fix that. It's all Bush's fault. That it? Now you could actually bring that up, x squared minus 6, and bring it up. Why would I suggest that? Well, you don't have to do as much work with the power rule as you do with the quotient rule. And what's the derivative of x squared minus 6? 2x. So you're not going to have a lot, except the chain rule. You got that 2x in what's inside. So, you know, that's something you could think about, or you could just do the derivative. I mean, the quotient rule. It's up to you. So I had it up here. The denominator times the numerator prime, and I don't know the numerator because it's stupid. Hold on a second. I'll bring it down. There we go. I don't know why. Times x cubed plus 4x plus 6 prime minus the numerator times the denominator prime all over the denominator squared. That's going to give us x squared minus 6. What's the derivative of this? 3x squared plus 4? Yes, Hubert. Thank you, class. Minus x cubed plus 4x plus 6 times what? 2x all over x squared minus 6 to the second power. 3x to the fourth plus 4x squared minus 18x squared minus 24, y'all check me, minus 2x times x cubed plus 4x plus 6. All over the denominator squared. And that negative is going to make this negative 2x to the fourth minus 8x squared minus 12x. Y'all check me on that. Distributed the negative 2x plus 3x to the fourth minus 2x to the fourth is x to the fourth. All right, 4x squared minus 18x squared is negative 14x squared. Negative 14x squared minus 8x squared is what? Negative 22x squared. Somebody check that. 4 minus 18 is what? 14 minus 8, negative 22, minus 12x, minus 24, over the denominator squared. Is that what y'all got? So you see, it's not that difficult doing derivatives, is it? Unless you suck at what? There you go, because the only derivative, the only calculus is where? From here to there. That's it. All right, let's try another one because I'm just going over stuff today. So let's go down here and find one that make y'all quit. Oh, there's a test question right there. Anything with a radical in it, it's going to be on the test. Write that down. So go ahead and do, that one's easy. That one's too easy. Go ahead and do all three of these. And that way I've done your homework for you. At least one section of it. I'm such a good teacher. I still have somebody not do the homework. I'm gonna do this one, that one would be, I'm gonna do that one probably with product group. You could do the quotient rule, that would get rid of the square root on the bottom. Yeah, we'll do it both ways. It's short, we'll do it both ways. I want to get y'all to come up here and do it on the board. That's what I want to get y'all to do. What do y'all think? X minus 9 times x to the what? Negative 1/2. So you can do that with the product rule. Or going to write that as radical. The denominator x to the 1/2 times numerator prime minus the numerator times the denominator prime all over denominator squared, which would be what? First, times the derivative of the second plus the second times the derivative of the first negative 1/2 times 1 is negative 1/2. X to the first will be 2/2. So 2/2 and plus 3/2 is what? Plus a negative 3/2 is what? Negative 1/2 is just amplified. And then what's half of 9? 4.5, or multiply it however you want to, which would be what? 9 over 2, which is 9/2. I'll just do 9/2. Be positive what? 9/2. X to the negative 3/2 plus x to the negative 1/2. That's a 1. So f prime of x. What's negative 1/2 plus 2/2? 1/2, Hubert. That's right, guys. X to the negative 1/2 plus 9/2 x to the negative 3/2. And then factor out a negative 1/2. You can factor out 1/2 x to the negative 1/2, but I'll just stop it right there, and then we'll compare it to the answer over here. So f prime of x is equal to x to the 1/2 minus, well, I'm going to keep this in brackets for right now, x to the 2/2 times x to the 1/2 minus 9x to the 1/2. And that's x to the 1/2 minus brackets. That's x 1/2, that's 3/2 minus 9x to the 1/2. And that's x to the 1/2. Ooh, I forgot my. X to the 1/2 minus x to the 3/2 plus 9x to the what? 1/2. And x to the 1/2 plus 9x to the 1/2 is what? 10x to the 1/2. Y'all check me. Minus x to the 3/2 over x. That can be simplified because you can cancel this x, which is 2/2. You can cancel this x with these two x's up here. I'm not getting some things that I got over here. Doing something wrong over here.